Wow, this is more students, this is more folks than I usually get in my classes. So I appreciate you guys all being here. And I want to thank the folks at Io-Tahoe for inviting me to talk to you a little bit about big data in healthcare. There's a bunch of them here, and they're up in the booth. I'm going to talk about their product in relationship to healthcare, but if you have any further questions, they're the folks to talk to. My name is Charles Boicey. I have a couple roles. I'm the Chief Innovation Officer at a company called Clearsense. We have built out a data platform for healthcare that we'll discuss today in context of Io-Tahoe. And as well, I'm a clinical professor at Stony Brook Medicine. I developed out and teach the graduate applied analytics program, data science primarily, data visualization. So that's a little bit about me. So let's kind of get into it. And again, this is very much in context of healthcare. How many folks are involved in healthcare? Oh, this is great. Fantastic. Wow. Now you'll know whether I'm telling the truth or not here on some of the things that I say. This is good. It'll be a good fact check. So since you could have kept the hands up, healthcare is extremely complicated. I'm also a clinician, trauma critical care nursing. We all know that it's very complicated. On the data side, it's extremely complicated. And if you think about data-driven healthcare, very, very, very complex. We just spent 10 years and God knows how many billions of dollars implementing EMRs, right? And we did that over a period of about 10 years. Let me bring the mic up. We did that over a period of about 10 years. And then in just the last few years, we've been, really concerned about, data and how to apply it. And in many instances, one of our clients, where I came from, University of California at Irvine, we had 168 systems. It makes it really difficult to do data science against 168 systems if all that data is in 168 systems. And if you think about it, even from an EDW perspective, whether you're an Inman or Kimball, Star Schema, you still have to make choices about what goes in when you're building those models. You can't bring everything in those models. You just can't do it. We'd be building that out for the rest of our lives and so forth. So very, very complicated. And really, not only that, year-over-year growth as far as healthcare data is concerned is about 36%. Even data outside of healthcare is growing exponentially. So at the end of this year, there's enough data generated within 2019 that equals all the data generated in prior years to 2019. So again, a lot of growth, a lot of data, and we really need to do something with it. So here's a wheel with a whole bunch of data types, and in context of healthcare in a big data platform in healthcare, we normally think about pathology, laboratory, radiology, clinical systems, the electronic medical record, but think about data from the instruments, streaming data at 1 second intervals or even sub-second, depending on what the use case is. Streaming data from ventilators, from smart pumps. Basically anything that can put out a signal can be brought into this type of environment, and it's actually being done. And we'll talk about the use cases around that, but primarily monitoring clinically in real time patients, their physiology and their reaction to various treatment and so forth. Staffing information, ERP information. If you think about other generated data within healthcare, clinical, yep, financial, operational. And then if you look outside of healthcare, I'm going to talk a little bit about a wearable project that's ongoing. So all the data that's being developed and communicated from the home environment. We have exposome data. Healthcare calls it social determinants of health. Exposome is not a new term. That's all the data around the environment. So we're not a product of our own physiology. We're a product of the environment, reacting with our physiology. And if you think about it, genomic information, image information, and I'll talk a little bit about imaging and genomics as far as storage and where the best place is to store it and keep it. Social media information. You probably asked me, what would you do with social media? From a marketing and communication standpoint for a healthcare organization, that information is vital. What's being said about about your organization, and more importantly, you'd be surprised of what's going on within your environments as far as people, Instagramming, tweeting out, and so forth. I've got an album of sleeping clinicians from various healthcare facilities across the nation where family members and patients have taken pictures of those folks and posted them out. So the point I'm really trying to make is there is a lot of data out there, and if you think about the systems within your organization, again, I mentioned 168. I have a client that has 1,200 systems in their organization. How the heck are you going to ingest that and make sense of it? Because we have to. We really don't have a choice. And then even more importantly, having all those data sets in one place is fantastic. That's a great endeavor and whatnot, but really understanding the relationships between those data sets, between those data points, absolutely essential. We have a term for folks that when you do this as a manual process, we call them, data wranglers. I'm sure you folks have data wranglers as well. The goal here is to minimize the amount of data wrangling and the number of data wranglers. They're few and far between, and there's far better tasks for those folks to be doing than manual normalization and so forth. Why did I get involved in this, and what is my passion involved with this? In healthcare, we kill about 100,000 people a year for various mistakes. Many of those mistakes are related to data and data inconsistencies, but more importantly, not having the right data in the right place, at the right time. My background is trauma critical care nursing, and there were many times that, if you think about how the EMR works and so forth, that data wasn't presented in a fashion that was immediate and actionable. Having to go to the system and look things up produces a lot of latency. So if you have critical lab values that come back and you're not being alerted to those, then that's an issue. If the correlation between physiological monitoring and those lab values come back and you're not able to make that connection, that's a problem. So from a personal perspective, this is really why I got into this. If I can get all the data in one place, make sense of it, build models against it, help clinicians on a daily basis, assist them in their care, as well as the folks in operations, finance, and research, then I've done something pretty cool. This is where Io-Tahoe really comes in and has really helped us out and done several things that I'll go through. But I think most importantly, it's allowed me and my team to expedite things. And you guys all know this, there are some EMR vendors out there that don't want you touching their data. They do everything they can to keep you out of it, right? Not only that, if you do get to it, you've got some issues there. There are vendors out there that have tables and columns that aren't very specific. Alpha and numeric column names and table names are not very useful, not very helpful whatsoever. Yet, we have to make sense of that. And I'll get into how we do that with Io-Tahoe in a second, but that really is the accelerator for us. And if you think about how many ontologies do we have, I know we have 7, and for those that aren't familiar with ontologies, that's your ICD codes, LOINC, SNOMED, RX norm, and so forth. And those, you guys have probably experienced this, they were not well applied in most organizations when we build out those EMRs. You can build out your LOINC codes in laboratory all the way down to the instrument. That was very seldom done. Yet there's a purpose for that. So a lot of what we're able to do with these applications are to make sense of the ontologies, and not only that, right size, what I call ontological right sizing of those various data sets. So let's take a little bit about look at Clearsense in this data platform. I kind of gave you, this is kind of a an overall view, if you will, not really detailed, but at the end when we ask questions, I'll be more than happy to answer any questions you might have. You'll have an email for me at the end. Absolutely contact me with any questions that you might have, or as you begin your journey and go forward, I'll be more than happy to help you out. So Clearsense is predominantly built on Hadoop, going a little bit lower than that, private cloud environment. And people ask me why a private cloud? While some healthcare organizations are still a little skittish about the cloud, that's okay. We can take care of that. So if you think about an environment that is high trust, SOC 2, PCI, and a few ISOs thrown in there for security purposes. So that's the underlying, private cloud, dual locations, one in Jacksonville, Florida, where we're located, one in Dallas. So on top of that, pretty much Cloudera's platform, formerly Hortonworks. Along with that, we have NiFi for that streaming, and we'll kind of go through the other components as we go through. So if you think about what's the first thing that you have to do, how many folks have legacy applications that are running for view only or occasional use, or for the folks in HIM to produce a legal medical record? That's something that we all have, and we all have to deal with. So the first step is to ingest all of those systems. Why? Because they can then turn them off. They have that data available for quality research and so forth, and they also have that data to print out the release of information for the folks in HIM. So we bring in HL7 direct. That's an easy one. You just bifurcate your interface. Fire inbound and out for those that that data that we need to grab from, let's say, an Epic or a Cerner that have the organizations turned on their Fire. Get and put within the database. If you think about flat files, you think about relational databases, EDW, whatever it is out there, social media we talked about, the exposome data, .gov data, CMS data, whatever's out there, you then bring in and ingest it. You then land it in. We have a SQL layer on top of Hadoop. Why? Because everyone in healthcare is SQL. There are very few folks out there that are writing MapReduce jobs. There are very few and far between. So we have to provide an environment that they're used to. So the next part that we see on the slide up there is insights, and this is where the folks in the applications from Io-Tahoe come into bear. So let's say I bring in one of those applications that I previously described that has 3,800 tables, and the tables are labeled as such as integers. Column names are integers. Well, that's not very helpful, right? One of our data engineers, our data wranglers, would take an inordinate amount of time to kind of go through that and map that. If you see off to your right, a couple columns over, there's governance. So this all needs to go into the data governance module. So what's the best way to expediently take care of that is to lay Io-Tahoe on top of that. And because we've worked with the application, and the application now knows healthcare because there's AI components within Io-Tahoe that allow our data wranglers, if you will, to, with confidence intervals, yep, that absolutely is a loin code, and that is a proper loin code for that data element. We can boost that up to 100%. So it's a bit of supervised as well as unsupervised learning. So the more systems that we bring in, the more the system learns, and the better and the quicker our analysts are able to take it to the next step, which is bring it into the catalog. Other ways that we use this, if I'm a data scientist and I can't wait for the data to get to the catalog section, I can apply Io-Tahoe against a data set, and if I'm looking for a certain loin code or certain lab values, let's say I'm building out a model for predictive model for diabetes type 2, and I have 17 lab elements that I need from a system, and I'm not going to go hunting and pecking and looking for it. This vendor didn't supply a data catalog because they don't want that data catalog out there, because they don't want to give away any of their secrets, if you will. So applying the technology to that data set, the data scientist now knows where that data is, and then can now go in and extract it. And that's one of the features that we use quite a bit, where we're looking into something particular, and we apply it against the data set, and we get that information back. This is an absolute accelerator for us. I can't tell you the time savings that it takes us, that's taken from us and allowed us to pursue. So what's next? So once we have that data, we understand what's there, we can then catalog it. It then goes into the data governance model. Everything within our environment is absolutely cataloged. Again, if it's been cataloged and you know where it is, you can go find it. Also, any products that we build or our clients build are also memorialized within that environment. So data science products, the models, dashboards, reports, everything that's produced is in that environment, as well as the lineage. Because we've all been in a room with clinicians, and they see a quality measure that applies to them, and they haven't done very well, and they want to know where the hell did that come from. We just pop that up on the screen, and you actually see the lineage, and they go, oh, okay, let's move on. So that's been very, very helpful for us. We don't apply schema in this environment unless there's a use case. So it's a schema on-demand environment, and you're probably asking, why? Early on, we recognize that we have no idea where healthcare is going and what data elements are going to be required to build models and so forth as we go forward. So we took the step of let's just bring in everything. Let's bring everything in its entirety and its natural state. And then as the use cases come up, we will then apply schema to that data. Where in an EDW environment, you have to make choices, right? You have to make choices of what's going in and so forth. And you end up leaving a lot behind. I'll talk about some predictive models with streaming data in a bit. We had collected over 8 years worth of that data before we started building those models. Had we not done that, we would not have had sufficient data to do that. So we've got it in place. Now what? We have several other modules within the environment. So if you think about it, if you have Tableau, if you have Click, or you have Power BI or anything else, you can use your tools against the environment. We do have a visualization layer. Again, I talked to you about HIM and legacy information, legacy viewer, and then a cohort discovery. Many of our clients are academic medical centers with a research component. The ability to do cohort discovery. Males between the age of 45 to 55 with a certain procedure on certain medications. Is there enough to make a cohort? And then, again, APIs out. If you have applications that you need to run against, you can do that as well. So that's kind of it as far as Clearsense, if you will, and how the Io-Tahoe applications serve us in that data pipeline. There are other component parts, but for now we'll kind of keep it at that. This is really our future state and how Io-Tahoe's tech fits into it. We're not there yet. But my goal is that this can be a completely self-service. You guys are used to configurable environments. Your EMR, you didn't write code for it. You actually did configurations and then implement it. So really the ability to bring the data in, enrich it, organize it, use it as you need to, and then analyze and so forth. We have client data scientists that interact within our environment. We do have a data science workbench, Python, R, Mathematica, SAS, SPSS, whatever your choice is, you can work in that environment. And then really the data is absolutely to serve clinicians, operations as well, the folks in finance, and then the folks in research. I'm going to do a couple use cases. Meharry Medical College, which is one of my favorite clients. We developed this out and we designed this out so that the safety net hospitals, the folks that are, I would say, technologically disadvantaged because of the cost of technology, could afford the same technology as a large organization such as Providence St. Joseph's, Cleveland Clinic, the Mayo, and so forth. And we've done that by use of a lot of different technologies that made it affordable, but most of them are on the bare metal side. And if anybody has any questions, they can, we can talk about that. So Meharry Medical College, a couple of things that's interesting. Nashville, Tennessee. They serve an underserved community, Nashville General. It's a predominantly black medical school. And guess what? They have a data science institute, and they've had one for 3 years. So they've been a partner of ours for 3 years. Their physicians, when they graduate, now they graduate with a certificate in data science, but as we grow faculty, they will they will eventually graduate with either a master's or a PhD in data science. So Meharry Medical College is using this environment for the purposes of creating, building physician data scientists, which is pretty cool. I think it's pretty cool. And what's really cool is they have folks from Johns Hopkins and others coming down to, kind of, how did you guys do all of that? So, so what are some of the things we've done there? Clearsense, as well as the folks at Meharry, and that team has exposure to all the components that we talked about. So if they wanted to do searches, if they wanted to do data science discovery, all of that, they have that environment open to them. Two in particular, we built out a model for predicting patients that are likely to be diabetic type 2 in the future, as well as hypertensive. What's really interesting about this, and if you think about it, when you do these types of exercises, and I always caution, 30-day readmits, patients that are likely to deteriorate, whatever the models that you're building, you should really have a discussion about, so we find these people, and what's the next step? You really got to plan this thing out. You don't just do the data science experiment and, throw it out there, do it. You really have to plan it through, because there's some ethical considerations, and I'll talk about one that came up in this project. So if you think about it, we're going to predict patients that are likely to be hypertensive or likely to be type 2 diabetics in the future. Well, guess what? I hypothesized that my hypothesis was that we would find patients that actually had those conditions that were, I don't want to use the term undiagnosed because it's not PC, but let's call it undetected. And as we did, sure enough, we did find patients that met those criteria. They did have a program in place prior to running the data, and they did call them in and made sure that they were treated. So that's a really good use case of applied data science. The other one that I like to talk about, because it hits home to me and my practice, is we talked about all that physiological data coming in real time. So coming across through HL7, through NiFi and Kafka, across a Spark environment, so that when the patient when that algorithm hits on that patient, the clinician can be notified. So, and it looks something like this. In the last 35 or 45 minutes, your patient's heart rate's increased by X, blood pressure's dropped by X, urine output's dropped, and these lab values have come in. 800 patients of similar, nearest neighbor modeling, similar, deteriorated. So you really need to check and make sure and put program in place to make sure that patient doesn't deteriorate. Early sepsis pathway as well works very well for that, as well as other potential disease processes that the patient might experience. So that that kind of concludes really kind of what I wanted to talk about. But more importantly, if we could, if you have any questions, if we could have a conversation, I'd really appreciate some feedback from you, as well as any type of questioning you may have. In particular, the folks here from Io-Tahoe are here, as well as up in their booth. So with that, and I know you guys have lunch and whatnot, I will open it up to any type of discussion. Questions? Yes, sir.
You mentioned that you had a SQL layer on top of Hadoop. What was that SQL layer?
Sure. So so early on, there's a vendor, a company called Splice Machine, that I worked with very early on and helped develop out primarily for the healthcare side. So basically, it sits on HBase with HDFS under it. And again, you really have to deliver in healthcare the data. You're not going to be able to flip everybody and teach them MapReduce. It's not likely to happen. Yes.
Is your data catalog a proprietary within, or are you using a third party?
Sure. So I will answer that by, there's a third party that I met 10 years ago and introduced them to healthcare that we're using. That product is Calibra. So we adapted it within our environment for healthcare. Yes?
So there are multiple EMRs, and when you get the data, are you still keeping the same format as this to the analysis, or is it standardized for different?
Sure. So many of our clients that do not have EDWs, or they would like it in a relational environment, will use the OMOP model for that. So some, but from a perspective of just taking it, no, we store it exactly how it's extracted. So whether that be in the Epic environment with journal files or web services or Fire, exactly how it comes out. And those that are really involved with Epic, there's our Epic clients. We have a link with Cogito, Clarity, and so forth. So there's some synergies there. All right, I think we're good. All right, thanks guys, appreciate it.